So we finished looking at arithmetic sequences in our last lesson, and an arithmetic sequence, as we should now know, is a sequence whose terms are generated by the constant addition of some term, okay, or the addition of some constant term, probably a better way to say it. And all we're doing is we're generating a list of numbers. Now, there's one formula which we have to remember when we're dealing with individual terms of arithmetic sequences, and that is T of n equals a plus n minus 1 times d. Okay, so T of n equals a plus n minus 1 times d. And in every question that they've asked you in arithmetic sequences, they will give you three of these and ask you to find the fourth. So they might give you 1, 2, 3 and ask you to find n, or they might give you a, n, d and ask you to find t of n. So it's very important that you understand what they stand for. A is always the first term. It's the beginning of that particular sequence. N is the number of terms that are in the sequence. D is that number that is a common difference between any two successive terms in your sequence. And T of n then is the actual term that you're dealing with, whether it's the 10th term or the 15th term, and that may also be a value. They may say to you that the 51st term has a value of 116. So that's where that will go, okay? So you need to understand what they are. Now we're going to move on from that. We're going to move from sequences into what's called series. And there's only one small difference. Instead of listing the numbers, we add the numbers to one another. So still a list. However, it's a summation, okay? That means that as you generate the terms, you add them to the previous terms in that particular sequence. So if a sequence was 2, 3, 4, 5, then a series would be 2 plus 3 plus 4 plus 5. So that's the only difference between the two. And because of that, because it's still arithmetic, both of these are arithmetic for the very simple reason, and there's only one reason why they're arithmetic, and that is because the difference between any two consecutive terms is 1. So no matter what two consecutive terms you take, the common difference is going to be 1. So they are arithmetic, okay? The key thing I want to talk about here in terms of being a sequence or a series is whether you're just simply listing them or whether you're adding them. Now what I need to point out is this. That T of n formula, a plus n minus 1 times d, that T of n formula is still valid for the series, because a series is made up of the summation of terms. So because we still have terms present in a series, that T of n formula is still valid. It's joined by a new formula, which is S of n, the sum of the first n terms. And that works out to be n over 2 times 2a plus n minus 1 times d. So a bit of an echo in there of the original arithmetic sequence formula, a plus n minus 1 times d. However, it changes slightly because now not only are we listing the terms, we're adding the terms that are in that list. So we call that S of n. So if I wanted to add up the first 10 terms, then I would have S of 10 and so on. So let's just take a series. Let's take a series at 3, 5, 7, 9, 11. Let's just say that this is the series that they give you. And let's say, for example, you're asked, what's the sum of the first 20 terms? Well, first of all, the sum of the first 20 terms is S of 20. So immediately n takes on the value of 20, okay? So n will be 20. A is always the first term, which is 3, and the common difference is the difference between any pair of consecutive terms. So the difference between 9 and 11 is 2, the difference between 3 and 5 is 2. So therefore the common difference is 2. And you simply feed those into the new formula, which is the sum of the first 20 terms, S of 20, which is n over 2, so that's 20 over 2, times 2 times the first term, so that's 2 times 3, plus 20 minus 1 times the common difference, 2. And then you simply use your calculator, or just do it in your head. So 20 divided by, that's 10 by 6 plus 19 twos. Now 19 twos is 38. 38 plus 6 is 44, and 44 times 10 is 440. So if I was to list the first 20 terms and add the first 20 terms together, I would get 440. So that's the only extra formula that we're going to be looking at in this lesson. So quite a short lesson today, more about practice on these things to get to understand when to use T of n and when to use S of n. So as we said already, an arithmetic series is a sum of all the terms in an arithmetic sequence. So if an arithmetic sequence lists them, then the formula for each term in that list is t of n equals a plus n minus 1 times d. However, because a sequence is only a list and a series is a summation, we have to use the summation formula, S of n, which is n over 2 times 2a plus n minus 1 times d. And yes, they are both in your tables, so you can look these things up in your tables should you forget what they are. I would advise you to commit them to memory, because at the end of the day, this whole chapter is only based on 4 formulas, okay? So I would commit them to memory so that you know which formula to use off the top of your head. If you forget, you turn to page 21, 22 of your tables, and they're there. In both cases, a is still the first term. A will always be t1, okay? D is the common difference, and n is the number of terms that we're dealing with in that sequence or in that particular series. Now that we've found formulae, it is a matter of knowing when to use each one. So when do I use t of n? When do I use s of n? And the answer is, listen to the question. If the question talks about an individual term, then you use t of n. If the question mentions the word sum, then you write down the S of n formula. So as I told you before, when you're doing questions like this and you recognize the vocabulary is prompting you to use a formula, write the formula down before you even use it. Okay, so if it talks about a term, write down the t of n formula. If it talks about a sum, write down the S of n formula. You mightn't use both, but at least you're showing the examiner that you understand there are two formulas involved here. One which generates the term of an arithmetic sequence, one which adds the terms of an arithmetic sequence and gives you the value of that particular series. But always just write them down as they are from the book before you fill them in. So here's an example. Find the sum of the first 100 terms of the arithmetic series 7 plus 10 plus 13 plus so on, plus so on, plus so on. Find what? Find the sum of what? Of the arithmetic series. So you go to your tables and you immediately discover that the sum of an arithmetic series has a formula. S of n equals n over 2 times 2a plus n minus 1 times d. So if you want to calculate this particular arithmetic series, the sum of this arithmetic series, you find what the value of a is, you find what the value of d is, and you find the value of n. So where are they? Well, first of all, the first 100 terms, n equals 100. Arithmetic series beginning at 7, that's t1, which is a. And finally, d is the difference between any two consecutive numbers. 7 and 10, difference is 3. 10 and 13, the difference is 3. So d is equal to 3. So now what do? Carry those three values up here and ask yourself, what is the sum of the first 100 terms? So S of 100 equals 100 over 2 times 2 times the value of the first term, which is 7, plus 100 minus 1 times the common difference, which is 3. So write the formula down first, blank, without any substitution, then substitute the values in their proper place, and then simply go to your calculator. That's going to be 50 times 14 plus 99 times 3. Now, what's 99 times 3? 99 times 3 is 297. So 297 plus 14, and then multiplied by 50, gives you the answer of 15,550. And that is your S of 100. So again, you're looking for the value of n, which is the number of terms. You're looking for the value of a, which is the first term, and d, which is the common difference. In that formula, please remember from the previous section we were dealing with sequences, that they can ask you to find the value of n, or they can ask you to find the value of a, or they can ask you to find the value of d. But whatever value they ask you to find, the other values have to be in the question. So you write down a list of a, n, and d, and then you discover what have they given you and what are they asking you to find. And by sheer manipulation of formulas, you'll be able to discover exactly what they're asking you to discover. Okay, so I've done this one here for you. In this case, we're asked to find the sum, so we use the summation formula, where n is 100, 7 is the first term a, and the common difference is 3. So when you fill them in, as we said already, you get 15,550. Next one, find the sum of all the terms of the following arithmetic series 11 plus 13 plus 15 plus 51. Now again, look, find the sum of the following arithmetic series. What's the formula? It's in your tables. N over 2 times 2a plus n minus 1 times d. Notice how I write it down as soon as I know I'm going to use it. Now, what have they given me? This is the key thing. So let's read. The only thing they've given me is the value of a, So A is the first term, which is T1, which is 11. And the only other thing they've given me is D. And D is the common difference between any pair of consecutive terms. It's 2 between those two, and it's 2 between these two, so it's a common difference of +2. What else have they given me? They've given me nothing about the number of terms. However, I do know that this particular series finishes at the term 51. So therefore, the last term is 51. See that? So in order to be able to do this particular question, I have to work out what they've given me, and from what they have given me, I've got to be able to then work back, manipulate the formula, and discover what they're asking me to find. Now, if they've told me what the last term is, T of n, because I don't know how many terms there are, that means that I'm also going to call in the following. Okay, so T of n is 51, A is 11, n minus 1, we haven't a clue because we don't know how many terms are in this thing, times D, which is 2. Now manipulate your formula. 51 equals 11 plus, multiply these two both by 2, 2n minus 2. 51 is equal to 9 plus 2n. Now subtract 9 from both sides. 42 is equal to 2n. So n is equal to 21. And there's the last part of that puzzle. N equals 21. So I'm now going to take all of these into the S of n formula, into this formula up here. And what is that going to give me? Well, S of 21, because n is now 21, is equal to 21 over 2 times 2 times the first term 11 plus n minus 1, which is 21 I should say, 21 minus 1 times the common difference, which is 2. So make sure you fill it in. N is 21, so both ends, the n here, n over 2 and n minus 1, yeah. Then A is 11, good, and D is 2. So just check that you fill them in properly before you use them. Make sure everything is in the right place. That should be 21. Let me just make it a little clearer. So that's 20. 21. Oh dear. 21. It's 20 when I take away the 1. So 21. Okay, now you can go straight to your calculator if you want and just tap it in. That's all you've got to do. And tap it in exactly as it is. So you've got the fraction of 21 over 2. Then you've got a bracket. Inside that you've got 22 plus 20 times 2, which is 40. And when you do that, you get an answer of 651. And that is the sum of the first 21 terms. So because we didn't know how many terms are in this list, I had to find out what term does 51 represent. Is it the 10th term? Is it the 21st term? Is it the 40th term? What? So I've got to take that 51 away for a little bit of prelim work to work out T of n. Because in order to get the value of n, I can't have more than one unknown variable in S of n. So I've got to work out the value of n, which I do by falling back on the T of n formula. And that will reveal the value of n, which I then carry into the information that's given and back into the S of n formula. And again, I have that done here for you. Firstly, what do we have? We've got the first term of A equals 11, and we've got a common difference of 2. That's not enough information. I need 3 pieces of information, so I've got to work out the value of n. The number of terms in this sequence, I don't know, but I do know that 51 is the last one. So I set T of n equals to 51. I fill in the A and the D value. I work out the value of n, which I showed you earlier comes out to be 21. And then I feed that into the S of n formula, and I get 651. Sometimes we can be asked to work with an individual term from a given series. So they might say to you, in this particular series, what is the value of the 21st term? Okay. Now, I want you to think about this for a moment. Let's just take again an arithmetic series. Let's take 3, 6, 9, 12, 15. And because it's a series, okay, we know that we're going to add them, plus, and so on, so on, so on. Okay, here's what I want you to think of. If I add 1, 2, 3, 4, 5, the 5th term, T of 5, is 15, okay? But I can also work it out this way. If I take S of 5, the sum of the first 5 terms, what do I get? Well, 3 plus 6 plus 9 plus 12 plus 15 is equal to 45, okay? And if I look at the sum of the first 4 terms in front of that, what do I get? Well, 3 plus 6 plus 9 plus 12, and that works out as 30. Look what happens. If I take the sum of the first 5 terms and I remove the sum of the first 4 terms, I actually end up getting the value of the 5th term, which is 15. So if they don't tell you what the terms in a particular series are, but they do tell you the value of the first number of terms, then all you've got to do in order to work out the value of individual terms is to go to the sum of that number of terms and then subtract the sum of the number of terms before that. So say, for example, I say to you, oh, find the value of the 10th term. What do? You work out s of 10 and you remove s of 9. Same thing as I did here. If I have 1, 2, 3, 4, 5, the 5th term is 15. Okay, we know that. Now, how do I find that? Add up the first 5 terms. Get s of 5. Add them all up. Then take away s of 4, and that isolates what we would call t of 5. So if you want to turn a series into an individual term, get the sum of the number of terms that you're looking for, and then remove the sum of the number of terms that are before that. Like this. For example, to isolate T6, the 6th term, we would take S of 6 minus S of 5. To find any isolated term, all you've got to do is work out its sum. So say, for example, I said, find T12. So what do? I get S12 and remove S11. If I want to get the 21st term, what do? I get S of 21 and remove S of 20. So basically what you're doing is you're adding up the first 21 terms and you're removing the first 20 in front of that to reveal the 21st term on its own. So to isolate the nth term, that's what we use. To get the nth term, you take the sum of those n terms and then remove the sum of the number of terms that are immediately before that. So here's an example. The sum of the first n terms of an arithmetic sequence is s of n equals 4n squared minus 3n. And the question says find t of n. Now, remember what I told you. If you want to find t of n, you've got to start with s of n and remove the sum of the number of terms before that. Now, what's before n? Before n is n minus 1. So what I've got to do here is write down 4n squared minus 3n, because that's okay for s of n. That's what s of n is. But then I've got to modify the s of n formula into 4 times n minus 1 to be squared minus 3 times n minus 1. Because if I'm moving back to the sum of the n minus 1 terms, then the n changes from n into n minus 1. And all I've got to do now is to work those out algebraically. 4n squared minus 3n, that stays the same. Minus what? Well, 4 times n minus 1 to be squared. It's a binomial. At this stage, you should know how to square out your binomials. It becomes 4n squared. So square the first one, n squared multiplied by 4. Square the last one, plus 1 multiplied by 4 is plus 4. Multiply these two and double the result is minus 2n multiplied by 4 is minus 8n. And then lastly, multiply minus 3 by both of these to give minus 3n plus 3. Okay, so what's that going to give me? 4n squared minus 3n minus, now tidy this up in here a little bit, 4n squared minus 8n minus 3n is minus 11n, and 4 and 3 is 7. So finally, 4n squared minus 3n, remove the brackets, minus 4n squared plus 11n minus 7. Straight away, your 4n squareds cancel. You're left with 11n minus 3n, and 11 minus 3 is 8. So that's 8n minus 7, which is t of n. So that's just working in terms of algebra. Okay, it's easy to do with numbers, but when you're dealing with algebra, if they ask you t of n, you write down s of n and you take away the modified version of the s of n formula where n becomes n minus 1. And now what do they ask me to do? Well, once you've found t of n, they're asking you, well, what's t of 100? Well, what's changed? The n has become 100, so therefore it's simply going to be 800 minus 7, which is 793. That's it. Okay, how did I get that? Well, t of 100 is equal to 8 times 100 minus 7. That's from the formula. Okay, and then 8 times 100 minus 7, 793. Okay, let's take this work example here from page 208, question 7. An athlete begins a training program for a 10-kilometer road race 50 weeks before the event. He plans to train each day for 49 weeks and the rest of the week rest on the week before the race. In the first week, he runs 2 kilometers every day. Okay, so week 1, he runs 2 kilometers. In the second week, week 2, he runs 2.25 kilometers. Okay. And in the third, week 3, he runs 2.5 kilometers. And so on, increasing his distance by 0.25 kilometers each successive week. Now, increasing his distance by 2.5 kilometers. That is D straight away. That's the common difference. That's how much you're adding to each term each week as we go along. So the question says, how many kilometers will he run each day in the 30th week? So I'm trying to get down here to W30. Now here's what I know. That because of the fact that we are increasing by 0.25 kilometers each week, A is equal to 2, D is equal to 0.25, and N is equal to 30. See that? The number of weeks. So you're dealing with first term A, which is 2, a common difference which we're told over here is 0.25, and then the number of weeks we're looking for is 30. But because it wants information about the 30th week, because that's an isolated week, that is using the T of N formula, which is A plus N minus 1 times D. So fill it in. T30, the 30th week, is going to be what? 2 plus 30 minus 1 times 0.25. And again, just go to your calculator. Ask your calculator what that is. 2 plus bracket 29 multiplied by 0.25. And that comes out as 9.25 kilometers. So by the time we get to week 30, he's running 9.25 kilometers each day. Part 2. During which week will he run the race distance each day? Now, first of all, what's the race distance? The race distance is 10 kilometers. So I want to find out in week N, he'll be running 10 kilometers. So week N, because we don't know what the week is, he'll be running 10 kilometers. So again here, I'm going to use the T of N formula. A plus N minus 1 times D is equal to 10. Now the values are exactly the same, but in this case, the value I'm looking for is the value of N. A is still going to be 2. So 2 plus N minus 1 times the common difference, 0.25, is equal to 10. So straight away you can see there's only one variable here, which now allows you to go and calculate that variable when you do a manipulation. So 2, multiply both of these by 0.25, plus 0.25 N minus 0.25 equals 10. So 2 minus 0.25 is 1.75, and 10 minus 1.75 is 8.25. So we get 0.25N is equal to 8.25. And if I divide both sides by 0.25, that will reveal the value of N as being divided by 0.25 comes out as being 33. So in 33 weeks, he's going to be up to 10 kilometers. And the last one, how many kilometers in total? That's a summation. Will he run on the training program, assuming he trains 7 days a week? Okay, now this is what you've got to remember, that we're going to be looking at the weeks in terms of their increase. But don't forget, in week 1, he travels 2 kilometers every day for 7 days. So in other words, if I want to look up how many kilometers would he have run if we were just taking the weeks as terms, I would then have to multiply that by 7 at the end, because he has run these distances for 7 days each time he has hit those distances. I hope that makes sense. Okay, so what I'm going to do here, what have we got? I'm just going to make a bit of space if I can. Okay, do I need anything there? Let me see if I can do it down here. Let's write down S of n first of all. So S of n is equal to n over 2 times 2a plus n minus 1 times d. Okay, that's the formula I'm going to use, because it asks me kilometers in total. So how many kilometers in total will he run on the training program, assuming he trains 7 days a week? First of all, how many weeks did he run for? He ran for 49 weeks. See that? So it says there, an athlete begins a training program for a 10-kilometer road race 50 weeks before the event. But he plans to train each day for 49 weeks and rest the week before. So I'm looking for S of 49, which is equal to 49 over 2 by 2 times the first term, 2 times 2. I'm going to get rid of some of this, unfortunately. So let me take some of this out here. Give myself a bit of space. Okay. Now it's better. More breathing space. So S of 49 is 14 over 2 times 2a plus n minus 1. That's 49 minus 1 times the common difference, 0.25. All right. But please remember that if I work out the value of this thing, that is working out the premise that he ran only once on one day during each week. Okay, so what I then have to do is remember that these particular distances are all repeated 7 times. So therefore I'm going to work this out first of all. Let me do this in the calculator. S of 49, and that's equal to 49 divided by 2. So turn on your fraction, 49 divided by 2, and then open your bracket. 2 2's are 4, plus 48 times, so plus 48 times 0.25. And then close your bracket at the very end, and you get an answer of 392 kilometers. But he ran 2 kilometers 7 times. He ran that 7 times. He ran that 7 times. So because each of these distances has been run 7 times, I've got to multiply that by 7 to get the total distance, including the repetition of each of those distances. And that gives me a final value of 2,744 kilometers. If he'd run in a straight line, he would be in Paris. Far better. Anyway, that's it. He didn't. He ran around circles around the house or something, around the garden or around the shed or around the what do we do in these socially distancing days? 5 kilometers. He could lap 5 kilometers. I don't know how many times, but that's it. That's all you can do. Round circles like a mad dog. Anyway, that's the question. Okay. Page 209, question 14. The sum to n terms. Stop. The sum to n terms. What do I do? S of n equals n over 2, 2a plus n minus 1 times d. Am I going to use it? Having a breeze. They mentioned it, so I write it down. Mark's already got. Of an arithmetic sequence is given by, so we also have S of n equals 2n minus 5n squared. Show that t of n is equal to 7 minus 10n. So here we go again. I want to go from a series to a term. Now remember what I told you. A term is found by taking its sum and removing the sum of the terms before it. Okay, so you're isolating t of n by looking at S of n minus the sum of everything that happens before that. So what is S of n? Well, S of n in this case is this one, 2n minus 5n squared. And now what I want to do is to remove S of n minus 1. So I rewrite this formula, but I change the n's for n minus 1. So 2 times n minus 1 minus 5 times n minus 1 to be squared. Okay, so now we've got to work this out. 2n minus 5n squared minus bracket 2n minus 2. And then here, be careful. N squared by minus 5 is minus 5n squared. Minus 1 squared is plus 1, so that's minus 5 at the end. Multiply these two together, double the result, and that gives me, and then multiply by minus 5, that gives me plus 10n. And all I've got to do now is tidy this up. So 2n minus 5n squared minus, let's tidy up what's in here. 2n and 10n, that's 12n. So you've got minus 5n squared. Then 2n and 10n is 12n. And minus 2 and minus 5 is minus 7. So finally, remove the brackets. Plus 5n squared minus 12n plus 7, because you've unleashed. If you remove the brackets, if you drop the brackets, the minus goes in and changes all the signs. Minus 5n squared plus 5n squared, gone. 2n minus 12n minus 10n. And lastly, plus 7 on its own, plus 7. What's that? That's t of n. That's it. There's your answer. And lastly then it says, show that the first difference, t of n minus 1, is a constant. Now what they're asking me to do there is the same thing I did with s of n and s of n minus 1. So if t of n is equal to minus 10n plus 7, then t of n minus 1 is equal to minus 10 times n minus 1 plus 7. So let's work this out. Multiply both of these by minus 10. Minus 10n plus 10 plus 7, okay, which works out as minus 10n plus 17. Now, what do I want to do with both of those? There's t of n, so that's t of n, and there's t of n minus 1. They want me to take t of n minus 1 away from t of n. So it becomes minus 10n plus 7 minus the result of this thing, minus 10n plus 7. Okay, let's see what happens. Plus 17, I should say. So we get, drop the brackets, minus 10n plus 7, minus plus 10n, and minus by plus 17, minus 17. 10n's cancel, plus 7 minus 17 is minus 10, which is a constant, as they asked. That's it. So you're simply playing around with s of n and t of n. But keep in mind, if they give you a series and you're to isolate a term, then you use the sum of that number of terms minus the sum of the number of terms immediately before that. That's one of the best ways we have to isolate terms from an arithmetic series. Okay, so that's it. That's as much as I'm going to do. I need you to practice that now. So I'm going to ask you to pause this video now and to go on to page 208 and 209 and to tackle the questions that are in there. And again, if you're working on them and you can't do them, send me an email, ask me for the solutions, and I'll show you how to make your way through any of those questions.